Hello and welcome to this episode of Zaptec Talks. We are relaunching our podcast now, going back to the basics. We're going to try to invite you into understanding why we're using EV chargers instead of sockets, why someone is saying it's not a charger, it's a socket. We will go into the details why it's much safer to use a charger, as we call it, instead of a normal socket. My name is Fredrik. I've been with Zaptec for 6+ years now. Before joining Zaptec, I was an electrician. So I did a lot of installation of the Zaptec Pro, which was the first product of Zaptec. And you can introduce yourself.
Thank you. So my name is also Fredrik. There's quite a few of us here in the company. I first joined almost 11 years ago. So I'm an electronics engineer and been through several roles internally in Zaptec. But I'm now working as a hardware architect and working with the teams to improve our current lineup and develop new hardware products.
Nice. I'm very happy that you wanted to join this conversation today. We'll go a bit technical for those of you who are interested in the details. I think we can start with where we began. I think I brought this.
All right.
Socket. Most of you, at least, maybe not the UK audience knows this, but at least many of the European countries, I think, are using this. And in the very beginning of EVs, we just plugged into this and charged from this. But then we saw the need or this is not very safe, we could say. Or would you say it's safe?
It's safe for everyday use for what it's designed for. So running your dishwasher or charging your phone, it's perfectly safe. And maybe in the beginning it was okay enough for cars because they had very small batteries. They finished charging quickly. They had small onboard chargers with low capacity. So, I mean, they wouldn't draw too much current. So maybe it started out as a good idea. But then I guess maybe when Tesla launched their Model S and other bigger cars came along,
with big
batteries became huge. They charge with a lot of power. If you plug your Tesla into this one, it would sit for 48 hours to refill. And that was never what this design was intended for.
No, because then these are normally designed for 16 amps as a peak power.
Yeah.
But EVs, they draw the peak over a very long time. And what happens to this then?
Exactly. So, I mean, some of them could be okay, but there's tons of different designs of these as well. And a lot of the times they're just added somewhere in the house. They're not necessarily planned for drawing this load. So you never know what's in front of this socket in your house before it reaches the supply of electricity in your house. So, I mean, this could go through a few light switches and a lamp in your bedroom before it reaches the car. And all that wiring is definitely never supposed to have an EV charging from it for hours.
Yeah, because I think we've seen a lot of pictures of these burned or melted because there has been like very low or bad connection in this. But I would say as an installer, I have also seen, as you say, not fire maybe, but something that could be a fire. Now, it's not our intention to scare anyone, but it's the fact that this one, if it's not having a cable from the circuit breaker box, it very often go to the light switch, to the socket in your bedroom, and then goes out. And then if it's a bad or poor connection in your bedroom, that's where the heat is kind of happening.
Yeah, it could be. And I mean, this is a very simple product. It's spent metal and it functions great, but there's no safety features or anything in it. If it gets too hot, it just keeps getting hotter till things start melting. There's nothing that shuts off. There's no safety features in it. So if something goes wrong, you'll never know about it before you start smelling smoke or something goes bad.
Yeah. But I think luckily here we are in Norway, where we have like very high EV adoption. It's also the legislation or the laws of Norway on the electric work. They require now to install a charger, as we call it, for if you're normally charging your car in your house, you need to have a charger. That's kind of how it is. You can still, it's still okay to use this in Norway, but it must be if you're traveling or if you're visiting someone who doesn't have a charger, it's very temporary thing.
Yeah, I would say so. If you have an EV at home or at your cabin, having an EV charger is the safe choice. If it's a place you know will be recharging time and again.
Yeah. We also brought with us some chargers. You can show this one,
yeah,
the camera, and I can show this one.
Absolutely. So here we have our two Go chargers. The one you're holding up is the Zaptec Go, which we created back in 2019, 2020.
Mm-hmm.
And of course, when doing this, we already had our Zaptec Pro series out there. We had some years of experience, but we saw that we could take out a lot of the components that we needed in the system charging space that's not needed in the home space. And also, as the market was growing, more modern components were available, making it possible for us to make the design more compact, more cost efficient. So, I mean, we can make a more reasonable device that more people can have at home without breaking the bank.
Yeah, because I think, without being an electronics engineer, I think this is like super compact. Being in the business, I've seen a lot of different chargers, and I must say this is one of the more compact chargers I've seen. So I'm quite proud that we have this. And now for you that watches this, you can see this without cover. So it looks, you can only see the electronics, but we also have behind us here how the charger looks when it's installed. What do we need inside of this to be able to charge a car? What is needed inside of, what type of electronics do we need to charge a car?
Yeah, so there's quite a few things. And as you said, we think it's quite cool what we created. And if you're an installer, you're probably seeing it already because we chose to keep the plastic cover, the middle cover, transparent so everyone can view the nice electronics that we put inside of it.
And a different color, I think. Normally people will see green color on...
Yeah, exactly.
Or is it just me?
I think it matters. So back when we were designing it, I think I used an analogy to if you have a computer, if you ever opened a laptop or whatever, if you see inside a MacBook, an iPhone or Apple products, if you open it up, it still looks really nice. It looks like high quality. It's perceived well. If you open cheaper brands, often it's green PCBs, they haven't spent time stacking things nicely. You just get the impression that this isn't as good as a quality product. So when designing this, we also wanted it to look good, even in the inside of it, not just the plastic outside. So we spent quite some time placing things nicely where we wanted them, and then we chose to display it through a transparent cover.
I think I forgot to mention you're the godfather of this charger.
Yeah, I was leading the team developing this one when we were doing it. So it's quite a nice process, and it's very fun to see how good a product it's become and how popular it's been and still is.
I think we did some good things for the installer, because the installer is an important has an important role in this ecosystem, as we can call it. So I would say the speed connectors, they have a huge impact on the feeling for the installer. It's also saving a lot of time instead of using like torque screws or whatever. So I think these, and of course these are a bit expensive in comparison to whatever screw things we could use instead.
Yeah, they are. But also from our side, it's a safety perspective. once you clamp down this spring-loaded connector, it will stay perfect forever. It doesn't matter the temperature, you can have vibrations, it's always going to stay locked. While if you have a screw and you torque it correctly with temperature cycles and vibrations, you still run the risk of it coming loose. Also, this one can accept solid wire, stranded wires, you can have ferrules. It's just made to work for everyone. And does add a bit of cost, but we think it's a quality sign. And of course, we want to take care of the installer. It should be easy to install. As you mentioned, the product is quite compact, but if you look at it, there is quite a bit of plastic around the electronics. We could have made it almost half the size, I would say, if we just packed it really tightly, but there would be no room for the electrician to work. It would be a terrible product to install.
I think we can show, because now we've taken off this cover, which is sealed by warranty. So if any of the installers remove this, they don't have warranty on the product. So I guess a lot of the listeners or viewers have never seen kind of how compact this is. Kind of now, this one is empty. It's nothing. It's just plastic. This is the charger.
It is, yeah. No, it's quite compact. And then, of course, normally the plastic goes over it, because one thing we wanted to do that we see a lot of other products maybe don't do in general is that we didn't want the electrician to have to deal with the electronics. You know, there's always a risk if you touch electronics, you could have an electronic discharge. Sometimes when you touch things, you see the spark, you feel it, it's quite painful. If you do that to electronics, you do it once and it's gone. The electronics is not working anymore.
So we won't sell this one.
Yeah, we will always have the plastic around it so that you don't have to worry about how you handle it. You don't have to deal with these delicate parts. We only need you to have access to parts that you should have access to.
But I think I want to go a little bit more back to, okay, this is a bunch of electronic components that is making sure that we can, when we plug a car in here, it will talk to the car, or at least do some communication with the car. And then something inside of here will decide that the car will have some power. And then something happens with the rest of the things. And maybe you can explain maybe how the power is going from where they are connected on the inlet. What happens with that power before it arrives to the car, and maybe what safety aspects that we have built into this, because in comparison to this one has a lot of safety things. You mentioned temperature. It can just be hot and hotter and hotter until it melts. Will that happen to this one?
No, definitely not.
Why?
So, I mean, the first thing that happens when you plug your cable into the charger and you plug it to the car is that there is communication established between them. It's called control pilot, or CP for short, which is one of the smaller pins on the socket, one of the two small ones.
The top ones, if you see inside.
And it's a really simple protocol. There's more advanced functions coming. We can get to that on the Go 2, or maybe in another episode to dive into the possibilities coming.
But how does CP work? Because I always... can you explain it short? Or?
Yeah, today it's really simple, honestly. So the charger outputs a signal, and it starts at plus minus 12 volts, and then it's pulse width modulated. So it's on and off for a certain amount of time. And the width of the on time is the charger that's aside, and that tells the car how much current is available from the charger. How much can I draw? So
this one can tell the car how much the car can use.
Exactly.
Okay.
There's no communication coming back from the car. We don't know anything about its state of charge, how much it can draw, or whatever. We can only push communication one way.
Okay.
So we start outputting this signal to the car, and then when the car is ready, the only thing that can do is adjust the level of the signal we have. So it starts pulling it down from 12 volt to 9 volt when it's ready. And then when it actually wants power, it pulls it all the way down to 6 volts. And when we read that's happening, then we can close the relays and we can start charging. But there's also a safety feature here, because the signal, as I said, is plus 12 volt and minus 12 volt. And there's a coupling with diodes here to make sure that it's actually a car pulling down only the higher voltage, not the negative voltage. Meaning if you lose your charging cable into a puddle of water or something is wrong with it and it just shorts or partially shorts the signal, you're not going to accidentally start charging. Unless you have the right network in the car, there's no way to make it just start charging without being connected to something.
So we won't have power on these pins if there is no car.
No, there's no
on the
way.
other side.
Even if there's a fault, if you drop it in a bucket of salt water that's conductive, you're not going to make it start charging.
But the thing on the car side, they call it charging controller, or
a charging controller, onboard charger, something in those.
So the charging controller decides what level of signal to give to the charger.
Exactly, it pulls it back. So already in the communication, there's safety built in, which is a good start. And then when the car actually tells us that it's ready to start charging, we can go ahead with our procedures to start it.
Yeah.
And if we take away all the smartness to start with, that we don't think about the cloud, the load balancing, all of that, what happens is that the charger usually does a self-test. Sure, am I ready? There's no faults, nothing wrong before I start. And when everything is passed, we send a signal to close the relay, meaning that we pass the power through the big relay that we have here, and it becomes available on the pins. After that, the car will usually spend a few seconds to read the voltage, make sure it's what it's expecting.
Happy with the quality of
the levels, the type of power. Is it single phase, three phase? In Norway, we have the special case of three phases without neutral, if the car will accept that or not. And then when the car is happy, it will close its internal relays or contactors and will start filling up the battery.
And then so now we kind of, the charging has started. So the power is flowing through our charger here into the onboard charger in the car. What do we do while the charging is happening? Are we monitoring anything, or are we just happy that charging started and let's see when it finishes?
There is things ongoing all the time, for sure. So if you look back at the charger itself, what happens in the first stage when the power comes through is that it goes through a sensor that is looking for any leakage current. Is there any current that could be leaking to ground, that could be leaking to somewhere, that could potentially harm you? And usually you have these devices inside of your circuit cabinet. In modern houses today, every single circuit breaker is a combination of a circuit breaker and a type A RCB. And what that makes sure is that there will never be more than 30 milliamps flowing somewhere else than back and forth in the primary conductors before it shuts off.
Just a small, since we're going a bit technical, 30 milliamps. Do you know why the limit is 30 milliamps?
No, not exactly.
I think if I'm correct, that's kind of the limit where it's lethal. So if the milliamps are higher than 30, then it starts to become dangerous for people and animals or living things.
Yeah, I would say it could probably be dangerous even at lower levels. You're an electrician. You've probably felt it once or twice.
Yes.
And it still hurts, even though it's low power.
It always hurts, yeah.
But the thing is, the one you have in your circuit cabinet is made to protect everyday devices and what's happening, and it works great. When we introduce an electric car, the grid that our charger and everything sits on is AC. It's 50 hertz modulated, switching from positive to negative all the time. And of course, the car's battery is DC. So somewhere along the path from the charger to the car, it has to be transformed. And that's happening inside the onboard charger in the car. And when you're switching up this AC current, turning it into DC, there is a risk of having DC leakage. So it's not the normal AC leakage that you could do if you have something wrong in your house normally. You have DC leakage. And the thing is how these RCBs in our house are built. They're built to detect if there's a leakage. But if you have a DC leakage,
from the car,
for example, it's actually makes the RCD stop working at really low levels. Already at 5 to 10 milliamps, the detection in your house could just stop working.
That's not good.
It's really not good. The principle of an RCD is that you have a core and you have a winding around it. And if there's an anomaly, there's actually a current moving, it will output a signal. But if you have a DC current running through this core, you saturate your core. There's something running, you saturate it, and then say you have a few milliamps of DC running, you saturate your core, you could suddenly have a big leakage of AC current, and you wouldn't see it in the RCB.
But that's leakage and protection of people and things like the property and stuff like that. But do we check more stuff, or is that
a lot more stuff? But I mean the leakage protection is a very big point in why this is important. You know, cars are metallic, they are conductive. If you touch the handle and there's something wrong, you are becoming the path to earth. Because the car is sitting on rubber tires, it's not connected to ground. But if you touch it, you are. And worst case, current can run through you.
So rubber shoes won't help you?
Not necessarily, it's not a guarantee.
Let's try, or not?
Maybe not. So it's become very important with the EV chargers and the standard that we're following, that this device has to make sure that we are protecting people, that you should never have people electrocute themselves by touching a car. So that's one of the most important safety features we put in there.
I just must say, because we have, of course, competitors, that we are not the only one in the world making these type of chargers. Some of the competitors, they don't have this device inside of the charger, so then you have to set it on the outside, because it's a hard requirement to protect the outlet of any charger. So individually, you need one for each outlet you have.
Exactly.
So if it's not inside, then you have to have it on the outside. You must have it.
But as far as I've heard, this device, if you put that in your circuit cabinet, it's more or less the same price as the charging station we are selling.
It's expensive.
The combination seems to be the better choice. And then I think one of the big things we see when you look at the charger is that we have a very big black box there, which is the relay from Panasonic currently. And we were actually the launch customer of this relay. This relay was purposely developed by Panasonic to serve in EV chargers.
Why? Is it so different from what they normally do? Or
if we look 15 years back or more and people starting to do these devices, you couldn't do it with printed circuit boards and components on here. You needed to do it more like a cabinet where you put contactors, you put controller units in it and so on, and wired everything together. Because it wasn't possible to pass currents at the level we're looking at through PCB components.
Okay.
So the big thing with this one that the standards calls for is that all the moving contacts are mechanically coupled. There's no risk of one phase staying in while the other are disconnected. It's always moving together, which is a hard requirement from the standards. It's the same for circuit breakers in your cabinet. If you have multiple phases, it's always moving together. So that's relay has a high rating. It will always protect you, and we make sure to test that while we develop and certify our chargers.
If something happens, I don't think it does, but if something happens to the relay, do we monitor that something has happened? Or
so one of the advantages of having this relay compared to having something in your cabinet is that we have a feedback contact. So we can actually see if it's opened or closed. We don't just have to guess on that. And if we look what's happening once the current has passed the relay, we come to the area where we are measuring the energy. So we are measuring the voltage of each phase. We are measuring the current flowing through. So we accurately know exactly how much current and energy is passing.
And some temperature sensors, or?
Yeah, I don't remember exactly how many there's in here,
No?
but we've placed them strategically anywhere we could see a temperature buildup. So we are monitoring the input connector, the relay, the temperature the current measurements, the output connector, and some other electronics parts around the unit. So we always make sure that we don't go out of the operating range of the components that we've chosen.
So that's a big difference between a normal socket, because it doesn't have any temperature sensor, it doesn't have any leakage detection, stuff like that. So that's everything together is making this much safer to use than a socket. And also, of course, the contacts are much more beefy. So you would not probably have that much heat building up on these pins compared to, because these are designed for high throughput, or how do you call it?
Yeah, they are. So the whole Type 2 contact that we're using in Europe was designed to handle 63 amps. So twice as much as we see being used. The 63 amp didn't really become a hit.
Because then you have to have 63 amp onboard charger in the car or the vehicle, which I guess would be very expensive, very big, very heavy, all that stuff. So.
Exactly. We chose to put that on DC chargers along the road instead of inside every car because people don't have that kind of power at home.
Yeah.
So having these pins, they are really made to handle a lot of power. They are circular pins, meaning that there's a lot of contact area between the pins connecting together. A lot of, I would say, normal sockets are maybe just damped metal. It's two flat metal parts together, and you push a round socket in between. So you have really small contact area, meaning there's more resistance, meaning more heat.
I think I can try to show, and don't laugh, but you have a long pin, which is the normal, like the thing you plug in. That's long, it goes in, but it doesn't touch along the whole length of the plug, even though it looks, I don't know how long it is, like 2 centimeters long, but it only touches a few millimeters on each side of this pin.
Probably not even that.
Maybe not even that. And also, I guess if you use this a lot, it wears out. So if this is an outdoor socket, you have been high pressure washing or vacuum cleaning the car over many, many years, and now you have an EV and then you plug that thing in, it's very little contact. It's like, and comparison to these pins where you hold the whole length of the pin instead.
And we actually have to test this also developing. Do you know how many times we have to test plugging it while we certify the product?
No.
So it actually has to survive 10,000 matings.
10,000?
10,000.
And that equals X amount of years in use, or is it just a number?
It is just a number.
Yeah.
But if you think of, if you charge every day for 10 years, you're
That's
still
3,000?
at below 4,000 times.
Ooh.
So the 10,000 is a lot. And it will even go past that. I know the connectors we are using is tested by our supplier to 20,000.
20,000. Shit.
And some of the reason we can do this is down to details as the plating of the pins. So for a normal socket, it's maybe tin plated or something just to protect it against corrosion. But for this one, which is supposed to deliver high currents for a long time, the connectors are silver plated, which is a much tougher plating. And it makes sure that you can have good contact between the handle you're plugging in and this one for a long time. Also adds some costs, but it makes sure that the quality stays high for many, many years. And another big thing with these sockets is that they have a lock integrated. So when you plug into the car and you plug into the charger, both sides locked. And I guess you maybe know why you do this.
If I think in the right way, I guess that if you have high power going through this contact and you pull, I guess if you go quickly, it's better, but if you go slowly, you will see that the current will jump from the socket from this into the socket, and then you explain.
Yeah, exactly. So I mean, if you just pull something out of the wall, there's no time for the device to stop drawing current or stop functioning. So you risk having an arc, which means like you have gases going, and that breaks down the components really quickly. And of course, for a normal socket outlet of 10 amps, it's maybe not too bad. But when we're handling 32 amps, 22 kilowatts in this one, it could be really bad. So the charging won't start until the cable is locked in both ends. And you can't just go pull it out. You can't just stop the charging abruptly. You have to normally use your car, or you use the app from Zaptec or an RFID key to stop the charging first before it will unlock the cable.
Yeah. And I know.
And also, I mean, it's a good way to prevent theft because the cable is also locked in.
And the cable is expensive.
They are, yeah.
So you don't want to steal them or have them stolen.
I mean, the price of copper is going up, so cables are becoming more valuable.
No, but this sounds. I think people now kind of understand the difference between the charger that we have and the socket, and maybe they will think twice to charge with a regular socket over time. As we said, you can use this in emergencies or one-time use every now and then, but this is the safest way to go, to have a dedicated charger. And I think we can also go a little bit back. You said that we are measuring power, and that measurement we use for safety, as you said.
Absolutely.
But we can also use it for making this telling, because this can broadcast what it's measuring. So we can use this as a device to kind of use power in a smarter way in a house or a bigger building. Because when you have the sensor, we know how much power is going through this charger. And then very often in a building, you want to know the things that are using power, and maybe you also want to control how much power they are using. And now you explained the pilot signal. Can we change that pilot signal during charging?
Yes.
And then
Absolutely.
something else can tell this charger to slow down, and the car will just slow down.
Yes, I think everything we talked about so far is happening in the bottom PCB, as you were holding up. So the thick, beefy power PCB on the bottom.
This one.
Yeah, so everything we talked about so far is happening there.
Mm-hmm.
But we, of course...
Safety, charging, like
yeah,
the power that is coming in and going out, it's never coming up in the top.
No, exactly.
I think it's difficult to see on camera here, but maybe it's twice the thickness.
It almost is, yeah. I think we're at 2.8 millimeters for the thick one, while the other one is 1.6, which is more a standard thickness for PCBs.
Mm-hmm. And that also helps with heat, I guess.
Yeah, we put a lot of copper in the lower one so that we don't have too much losses and current goes through it. Because, of course, all the power that goes into the charger, you want to go into the car. You don't want to lose it inside of the charger as heat. Mm. But yeah, there's one more board, and that's our communication board. So that processes all the data, and then there's an option of sending it to the cloud. It can go to our cloud, it can go to operators' clouds, and you add a ton of options, which you can probably deep dive in a later episode. Mm-hmm. But on the Go, we chose to give it two ways of getting this data to the cloud. There's Wi-Fi, or there is 4G. Mm-hmm. So there's always a way of connecting it. Mm. And of course, there's a two-way communication, and this can be used in a lot of smart ways.
Mm. I think only the imagination sets the limits in a way. Of course, we have APIs that you can use, and maybe there is not very maybe you can't use it in all imaginable ways, but I think thinking alone, you can adjust how fast it's charging. You can stop charging, you can start charging, and only with those options you can create a lot of different scenarios. It's kind of, that's the all you need to do. I wouldn't, because smart, I think smart is everything is smart. So,
yes.
That's not the smart thing. The smart thing is when something is happening by itself, you don't have to do something. Oh. That's when it's, in my mind, smart. So we're just exposing the ability to do this. Of course, we have our own solution that you can use also, but if you don't want to use our solution or something else, you can at least control this charger and do a lot of good stuff with it. Yeah,
you can. And also, as we have two chargers. I think you were showing the other board just a minute ago. Maybe you'll hold it up as well if you want to see it. But we also have our Go 2, which if you look compared to the other one, it's quite similar, but we added even more features. And you were just talking about the energy measurement, which we had in the Zaptec Go, and it's actually almost identical in the Go 2. But for the Go, we said, trust us, it's accurate, we've tested it. And it is. I mean, it is pretty good. But we didn't really have a way to prove it. So for the Go 2, we chose to go through certification to prove to everyone that it's accurate. So the metering or the energy measurement happening in the Go 2 is actually as precise as the meter you have at home. So, I mean, normally at home, you trust that your electricity company is billing you the correct amount. And we wanted all the users of the charger to be able to trust it the same way. So we went through what's called MID certification. It's a European directive for measurements to make sure that we can prove that every single device is accurate. So in our production line, every single device goes through calibration and verification to make sure every device is accurate. So now we also have super accurate measurement of currents that we can use for billing purposes. If your neighbor want to borrow your charger and you want to get paid from him, you can tell him exactly how much current or energy he drew, and you know it's accurate. So that's a very nice feature. Also, we wanted to think forward with the new charger, so we made sure that the measurements are bi-directional.
That's exciting.
Hopefully, in not in too distant future, electricity can flow from the car back to your home, back to the grid. And of course, you want to measure precisely how much current is going out of your car. Because you don't want to give it away for free.
Money in, money out. But I think now I really want to talk a lot about vehicle to grid, because I think that's one thing that a lot of people are having questions about. But I think we have to end this episode now. And I would say thank you for listening, tuning in, watching, listening. And we will come back with a new episode. Maybe the next topic will be vehicle to grid or something similar, because I guess we could talk for at least an episode only with vehicle to grid.
Oh, definitely.
Yeah. So thank you for tuning in. Come back to Zaptec Talks next time.